In the age of sail, surviving the bottom of the world earned you a very specific status symbol. Tradition held that any mariner who made it through the passage was entitled to wear a gold hoop earring and could legally dine with one foot on the table. It was a place that inspired absolute dread in hardened sailors and scientific explorers alike. After experiencing it firsthand, Charles Darwin wrote that a single sight of the coast was enough to make a landsman dream for a week about shipwrecks, peril, and death. Geographically, Cape Horn is a rocky headland at the southernmost tip of the Chilean archipelago. At 55 degrees south, it marks the final rocky outpost. Zooming out, we see the Drake Passage, an 800-kilometer stretch of open water separating South America from Antarctica. Over 3 centuries, this specific stretch of water swallowed over 800 square-rigged ships, claiming the lives of more than 10,000 sailors. Which raises a purely physical question: what exact combination of geographical forces transforms this particular gap of ocean into a meteorological meat grinder? This view from the South Pole shows the prevailing global wind bands of the extreme southern hemisphere. Down here, weather systems fall into latitudes known by sailors as the Roaring 40s, the Furious 50s, and the Screaming 60s. These winds circle the lower globe entirely uninterrupted by any major landmasses. With thousands of miles of open ocean and nothing to block them, they build immense, terrifying speed. But right here, they hit a wall. The towering peaks of the Andes Mountains lie to the north, and the ice-locked Antarctic Peninsula sits to the south. These two opposing landmasses act as a planetary-scale funnel. They catch that uninterrupted high-speed wind and violently compress it, squeezing millions of cubic miles of air directly through the narrow Drake Passage. The result is a hyper-aggressive weather system. Ships are struck with zero warning by squalls packing hurricane-force winds, whipping the sea into a blinding whiteout. The Drake Passage functions as a massive, geographically engineered wind tunnel, designed by the landscape itself to batter any passing vessel. But the air is only half the problem. Below the surface, deep ocean swells roll endlessly across the Southern Ocean, gathering massive amounts of kinetic energy. Looking at this cross-section of the ocean floor, we can see a hidden bathymetric trap. Just south of the Horn, the deep ocean basin abruptly slams into a shallow continental shelf. When that deep water wave energy collides with the shallow shelf, it has nowhere to go but up. The waves compress horizontally and are forced violently toward the surface, forming incredibly steep peaks. Add in one final variable: a massive, eastward-flowing ocean current that is constantly colliding with the opposing westerly winds, churning the water from multiple directions at once. This exact collision of a shallow underwater shelf, opposing currents, and compressed wind engineers what we know as rogue waves. These are 30-meter walls of vertical water, fully capable of snapping a wooden hull in half. For centuries, mariners had no choice but to face this exact physics equation. The route was discovered in 1616 by Dutch merchants looking for a way to bypass strict corporate trade monopolies on the known sea routes to the Far East. It became a brutal necessity. Heavy, square-rent commercial clipper ships hauling Australian grain and South American nitrates had to stubbornly punch their way westward, sailing directly against the teeth of the wind and the ocean current. The crews endured a freezing, sensory nightmare. They operated complex rope rigging with bare hands in sub-zero sleet, all while scanning the dark, violent swells for the constant threat